Sure. All right. Good afternoon, everybody. Welcome to our CDS Lab webinar series. This is the concluding webinar. We have our Water Nexus section for the summer. And I'm very happy to welcome Newsha, our member, RCM member, to moderate the session. And also we have our student Becky to introduce our panelist and moderator. Becky, go ahead.
Awesome. Thank you everyone for coming today, taking the time to be here. I am honored to introduce the panelists for today. First, we have Dr. Chingwen Cheng. She is the program head and associate professor of landscape architecture, urban design, and environmental design at the Design School of Arizona State University. Dr. Cheng's teachings, research, and practice engage transdisciplinary approaches for climate justice design, integrating environmental justice theory, spatial mixed methods, system design, nature-based solutions, and working with communities for co-developing research agenda and strategies to enhance community resilience and sustainability. Second, we have Dr. David Sampson, who is a senior sustainability scientist in the Global Institute of Sustainability and Innovation at Arizona State University. Dr. Sampson's current research focuses on the development and implementation of urban water policy and a planning tool labeled WaterSim 5, an open source software program that can be used by students, faculty, and water resource managers. Third, we have engineer Alfred Heble, an international environmental consultant and owner of Consult in Stuttgart, Germany. Engineer Heble has more than 35 years of national and international experience in design, build and optimization of water and wastewater treatment plants, including sludge treatment and sludge utilization in the municipal and industrial water sector. His current focus is on application of advanced treatment, elimination of micropollutants, treated effluent reuse, sludge, and biogas utilization for future fuels. Lastly, I would like to introduce the moderator for this discussion, Dr. Newsha Ajami. She is the Director of Urban Water Policy at Stanford University. Dr. Ajami is a leading expert in sustainable water resource management, smart cities, and the water energy food nexus. She uses data science principles to study the human and policy dimensions of urban water and hydrologic systems. Her research has been interdisciplinary and impact focused. With that, I pass the floor to Dr. Ajami.
Thank you so much, Becky. And Cecilia, I'm really delighted to be here and moderating this panel. As many of you, if you live in the Western US, know that we are dealing with a severe drought right now, both on Colorado River and entire California. And this is obviously nothing new. We just got out of California, at least just got out of a drought a few years ago, and we're back at it again. So a lot of the topics that we're going to talk about today very much is sort of essential to the way that the water sector transitions as we're dealing with more severe and frequent droughts, and as our water supply are dwindling because of the change in the natural systems that we built our infrastructure for. As many of you know, the Western US would not be able to accommodate this many people if we would not have built such a sophisticated and a complex infrastructure system that we have. And obviously that infrastructure system has helped us to grow economically and socially over the years, but obviously it's reaching the end of its lifetime. And the question is, the approach that we had, which was very much dependent on conquering nature and trying to kind of overcome our limitations, natural limitations, is really going to help us transition in this 21st century as we're dealing with climate change, population growth, aging infrastructure, and environmental degradation we are experiencing. And with me, as Becky kindly introduced everyone, you can see we have a great panel. They presented very interesting talks during the past few number of weeks, focusing on nature-based solution, re-engineering our cities, and how we can sort of foresee where we need to go with limited water. And I am excited to ask them a number of questions and have this discussion about what the future holds as you're dealing with more challenges. So I guess for those of you who might not have been here during all the talks or some of the talks, I'm going to ask every one of our panelists to maybe walk us through at least one of the problems that they consider to be very important, or one barrier that they think it's very important in managing our urban water. And Chingwen, I think I'm going to start with you, and then we go to David and then Alfred.
Okay, thank you, Newsha. Yeah, thanks for organizing this panel. I think it's great to have a time for a deeper dive discussion. And I think from my background in landscape architecture, urban planning, and thinking of how we design with water, and from the infrastructure, technological systems, and also social ecological systems together. The challenges or how we could think about moving forward to be a more transformative and sustainable resilience water systems would be how to work with community. That community, that means multiple stakeholders, and address those issues, and then make sure it is also equitable, it's just. Because a lot of solutions, we don't want to perpetuate the injustice systems that we already in already. And also we don't want to perpetuate the unsustainable systems we have been designing in the past. So just give you a quick nutshell.
Great point. So equitable and sustainable transition as we are looking at future of the urban systems. Thank you, David.
Yeah, so I tend to take large picture views of most things. Our current problems today with water shortages and inadequate water supply for the over 40 million people that rely on the Colorado River water really has to do with the structural deficit that's been on the system for almost a century now. So with a 1.2 million acre foot structural deficit, we've known it's been there. For those who don't know, the Colorado River was allocated during one of the highest flow periods in the history of the flows that we have on record for the Colorado River. We allocated the water. This is how much you get. And of course, here we are today now with more below normal flows. It all stems from people's unwillingness to give up the rights that they have, and an unwillingness to recognize that we've been in this really for almost a century, and we just need to just deal with it and come to terms with it.
So revisiting our water rights system across the West.
Yes, yep, exactly.
And I love that term, structural deficit, because I think it's very much highlights the reality of what we're facing today. And actually for the past 20, 30 years, we have been sort of on and off at it, right?
Right.
Okay, Alfred.
Yeah, thank you, Newsha. Thank you, Becky, for this nice introduction. Okay, so my point of view, I would like to summarize it in this way, that I think the fact is that due to all this stuff with climate change, you know these arguments very well, but in general, we have decreasing groundwater levels. We have also the situation that in dense areas, with big cities, we have increasing pollution effects with micropollutants. So having the future perspective that we will have very increasing changes in climate, the requirement of protecting the important groundwater source for drinking water is nothing to discuss. It has to be done. So everything to improve and save the drinking water and the groundwater sources has to be done. No discussion about that. We shouldn't discuss what to do this and that. Every things which improve and save the water sources have to be realized step by step. My approach is in terms of advanced wastewater treatment and wastewater reuse is that this is a source which with a high capacity, and it is available 365 days through the year. So this is also not all, but it is one big part which we should study and we should investigate, and we should start not tomorrow, we should start today. This is I'm 100% convinced of that. And so the measures are complex and the regional implementation is complex, and this has to be studied and has to be approached as soon as possible. This is my general statement.
So pollution management, source protection, which I think it's a very, very important point, because just for example, the city of Los Angeles have been trying to add groundwater as one of their water supply sources as they're trying to diversify their water supplies. And they're having a hard time because one of the groundwater basins they want to use as part of this process is has a lot of industrial pollution, which costs a lot of money to clean up. So the question is, how do you protect your sources, or how do you clean them up and then also make sure you are preventing future degradation as we are sort of transitioning? So, you know, let me go back to Chingwen. I think, you know, I'd like you to kind of maybe elaborate a little bit more on this whole concept of co-design. And when you're talking about nature-based solutions, maybe this question is two-pronged. Like, one is, how do you incorporate nature-based solutions within our existing sort of legacy infrastructure? And then the second thing is, as that by itself is very difficult, how do you also bring in the discussion around equity and justice to make sure we are not leaving people behind as we are transitioning?
Yeah, thank you. That's a good question. Well, first of all, just to define if people who maybe missed my lecture, or what is nature-based solution we're talking here. This term kind of invented probably a decade ago, probably by the United Nations, and it's more popular in Europe. That's what I found out. But recently, this term has been used, started here in the US as well. But the concept basically is the strategies that will simulate or apply ecological principles and to help to address social issues. So that will help to enhance the ecosystem functions and structures, and it's like ecologically based design. And if you think in this broader term, actually green infrastructure, which this term is more widely used in the US, it's not too much difference in that concept. But the key, how we retrofit, or people think, yeah, how we do this, in an already built environment. I think one opportunity now is many cities, we have aging infrastructures and now needs upgrade. And actually, oftentimes you will see how your city, right, repaint the asphalt and, do all this maintenance or digging out the pipe, replace again. If you think of all this investment that we have in the city, and if you think all this, point of investment, can we do something better? Can we invest in something more innovative, sustainable? And that's the opportunity to actually bring in nature-based solutions. And the other thing is that every homeowner, every property, owner can also have your own authority and the liberty, and think about how you want to, retrofit your own gardens and lots. So there are multiple ways thinking about at core scales, right, from the lot scale to the neighborhood, city, and the nation. So, but thinking about all this investment, we already going into the infrastructure redesign. That's an opportunity for all of us to think about. The second part about equity, it's a little more complex. When we talk about justice theories, we talk about distributive theory, justice, right? It's the outcomes of the project. We talk about procedural justice. That's where the decision-making process in each of this investment, in each of this nature-based solution project, who are involved in the decision-making, and it's designed for who benefits, who pays, whether those are equitable. And we can think even beyond this process and product, but also think about recognitional and restorative justice. Because in some community, many communities that have been experiencing injustice systematically under institutional discrimination for generations. So how can we recognize that past harm? And when we rebuild or work with community, and how we can recognize the past and reconcile and move forward to a more sustainable and just future with community. So in that design process, that's another goal. We can incorporate it to be a more just future. And of course, this will be beyond one generation. So this is generational justice, thinking about sustainability. So for every project we are investing, can we think about long term? So I'll offer these 4 areas of justice.
Maybe I'll ask you a follow-up question on this, which is, I think you're absolutely correct with the fact that we are transitioning. Obviously, we have all this infrastructure money that hopefully will make it through, and we are considering all this different infrastructure designs as we are thinking about how we would spend the money. But my question for you is, obviously we all realizing how important it is to incorporate nature in this process. However, when you're thinking about finding money and building, sort of measuring the performance of these systems, it becomes very difficult sometimes to justify investment, especially when you have this legacy performance measures that prefers those old infrastructure model to the new ones. So how do you transition that? How do you sort of think about, the idea of, okay, so nature-based solution might not deliver as much, clean water as a wastewater treatment plant, but, incrementally can improve our watershed and our system in so many different ways?
Well, I think that actually need to probably revisit, that evaluation assessment criteria that we rely on sometimes. Actually, maybe even the kind of fundamental what we think is cost benefit analysis, right? And if you just using the dollar values and on things, and very often what has been neglected into that analysis is the abusing of laborers, right, inequity, or is the biodiversity losses, and how can you calculate that, right, value that into that assessment. So the same thing, thinking about why we should invest in nature-based solution, but I will also kind of say nature-based solution is not a penicillin for all the problems either. I would not say, we just use 100%, nature and try to resolve all the social, structural issues. I would not even say that either. So actually it is a combination of how we balance. Because like Netherlands, for example, the country in all 60% under sea level under the sea level. So without their infrastructure, I mean, the whole country will not be able to survive. So it's a fine balance. But even in the Netherlands, they also recognize, right, they have to also incorporate nature-based solution, because it's simply one is that the engineering solution alone cannot resolve the issues we are facing, especially under climate change. And so because it's so uncertain and they're so extreme, we cannot just keep building huge basins or huge infrastructure to try to be defensive. So we have to think about the mindset shift is how we can better live with nature, live with water. This is actually more of a resilient mindset shift. So the flooding is one of the natural cycle, right? In rivers and the water cycles. And again, on the climate change, it's almost our past design has been based on the past climate pattern. So now, how can we design on the climate change? Actually, nobody actually knows. So the best way also, I mean, we cannot keep investing all this hard infrastructure, and the other dilemma will be it will actually increase the risk, right? Thinking about the dam, you build a dam when the dam broke, that's actually the more devastating disasters, right? So there's all this kind of risk we have to think about, and then how can we prevent? I think the mindset of risk management now is how can we prevent from people getting hurt and damage of the property? So how we can minimize that cost, and while people can increase their mindset of resilience and adaptive capacity, is it's okay to flood, because that's part of our natural cycle for the water to go. So now the question is how we design for where to allow water to go safely, and in a city you can do a multiple different kind of solution together. Also designing the stormwater management flood system. It's not one design instrument; it's a system approach. So it's both nature, open space preservation to a very, engineered solutions. I mean, there is a broad spectrum, right, from the gray to green infrastructure we can apply. So this is a, very systematic thinking. But we also need to acknowledge, the recent news in China, for example, they were blaming why, we invest in sponge city and why it did not work, it's still flood. But we need to acknowledge again that the infrastructure design has its own design capacity. That's what we designed that for. So it could not impossibly to design to accommodate, all capacities. And again, under climate change, it's almost impossible to design the whole city as a huge basin, right? So how can we live with floods? And that will be the, again, mindset shift. So people have to think now, it's not, I cannot totally prevent the water to come in the first floor, but how can we minimize damage? So that can be adaptive design to, have connection on second floor, or how can we make the parks and underground system be, more adaptive, can be used when it floods. So there's really multiple dimensions we have to think about to be a more sustainable city.
Sure. So it's like a multi-benefit, multi-dimensional approach to the problems rather than like individual. So David, maybe a good transition here to some of the work you have done with your simulation model. And I know you have been trying to sort of look at this in a system level, defining system in different ways. I'd like to kind of go back to your earlier comment about the structural deficit and sort of trying to reevaluate the water rights system, and then maybe sort of try to see how do you think, what kind of role do you think the work that we do at the academic areas with our models and tools that we are building in order to help this transition process to a better understanding of our current system and how, like, helping the policymakers or decision makers to come along and transition to a different reality?
That's a very good question. Thank you. So the modeling really needs to be structured so that people can relate to it. And there's so many different approaches to modeling to address policy questions, and it always comes down to scale and purpose and what can you do with your model to convince people of the policies that you can implement and how that might impact their lives and society. So ever since the inception of my work here at ASU, it's really been really big picture things. So we've always addressed really big picture policy questions. We don't operate day-to-day management questions of how to manage water. We're always looking at regional, metropolitan scale challenges to water. Right now I'm working on a model for the whole Colorado River Basin. And that model then attempts to incorporate those important driving variables and issues that people care about for the whole 7-state region. And so we're working on developing, using vetted scenarios with climate, land cover, land use change, using vetted policies that people can relate to, that is not a hurdle for them to meet. And then looking at how cooperation and or sometimes antagonism interacts with the changes in the climate and the climate system and the riverine runoff, and how that's impacted by the current water rights. Truthfully, I think from my perspective, it's all very simple. Dealing with things like the structural deficit, I'm not even sure that we even need to change water rights. I don't see how that would even happen in the West. I think we need a reality check, and people, if everyone took across the board 17% reduction in their own water rights, we'd meet our challenges right now. You know, I all the modeling I've ever done, and I don't, since my last talk, I've submitted a paper on the coupled food, energy, water model that I've been working with. And it comes down to some very simple, basic concepts of system management. Reduce population, use your water more efficiently, use your energy more efficiently, grow crops that are more water resilient, that use less water. It's very simple stuff. And you can get people on board with conserving water. I don't think people have a problem with that. And I think if you could just show people the benefits of just simple activities, simple changes in behavior that they can do in order to reduce their water use and then the city water use, I think the problem is easily solvable. I really do think that.
I think this is, I appreciate your perspective on trying to get everybody on board of reducing their water rights by a certain percentage and sort of moving along. One question I have for you is, you said reducing population, and I'm sort of, this comes up in California often too. And obviously we can't stop people from moving to different regions or different cities. So reducing population, unless people decide to migrate because there's no water, otherwise it's not really a practical solution. But I think to your point with conservation and efficiency, we have in the West, at least in California, we have been able to sort of feed more people with the same amount of water, even though our population sort of has doubled, we are still using the same amount of water. So
Right.
it's just like it gives you that space that you can grow within. Where is Arizona in that? I guess that's, I know this is a little off topic, but I'm assuming you're sort of looking into that. I would love to hear your perspective on where Arizona is on that end.
So to get to your reducing population, it's not really a pie in the sky concept for me. I think there are incentives to discourage people from moving into an area, is kind of how I view reducing population. You can't tell people where they can live or move, for sure. In fact, Arizona, since 1980, roughly 85, has been using about the same amount of water while we've increased about 4 million people. Well, not quite 4 million people. So we've had a pretty steady decrease in our water use per capita over time. Of course, we're losing agriculture out of the metro area, which uses a lot of water. And as I mentioned in my talk, agriculture in Arizona uses, depending on the county, 50 to 70, 75% of the water use in the county. So just inherently by losing or switching agriculture for houses, we're using less water. So Arizona's been pretty good about being more efficient with water. And we've done that without cities instituting conservation measures. I mean, people, this is all seamless to people. They don't even know what's going on. They haven't been told how much water they can use. They haven't been allocated a fixed amount of water that they can use. Not yet, So this is all happening in the background.
Hopefully coming soon. I mean, we talk about in California that do we really need ornamental grass, and do we really need California to look like England, considering how much less rain we receive? But people really are mindless or heedless when it comes to water. They just don't know.
That's true.
So that was, thank you so much for that, David. I think maybe this is a great sort of transition to Alfred's topic on source protection and actually reuse. And Alfred, I think my question to you is a little sort of multidimensional. One is, I would love for you to talk a little bit about sort of the treatment technologies and wastewater treatment and sort of reuse concept. Another side of it is, where do you see reuse coming into the process of this conservation and efficiency that we talk about in cities and communities, right? So at some point, if we take less from the environment and recycle water as many times as we can in different settings, that would sort of reduces the amount of dependence we have on the natural systems. I'm just wondering what your thoughts are on that as well as part of this discussion.
Yes, okay. Let's try to explain my thoughts about that. The first thing about wastewater treatment and technologies is that having in mind that we live in a cycle economy, and everything which we produce as waste and we have to discharge it leads to a cycle and leads to a certain pollution. So the main approach from my perspective is, when we're talking about treatment and treatment technologies, is that we have to make a design, in the case of wastewater treatment, meaning a full carbon, nitrogen, and phosphorus removal. So the pollutants, which, if they are not eliminated to a maximum, will in some places lead to a pollution effect. Latest when you put the waste somewhere for the deposits and so on. So the design of the wastewater treatment plant requires this approach. This is state of the art. The technologies are clear. A second point regarding the technology I find very important is when we include the food, water, energy nexus stuff. regarding the energy, if you make the design in the wastewater treatment plant to have primary treatment, you have excess sludge, and you have a digestion concept where you maximize the production of biogas, and you use and you have a full elimination, so you maximize the biogas production. You will see that, especially for very large wastewater treatment plants, the biogas production and the biogas transformation, either to biomethane or what is a really new approach, is if you go to plasmolyze, methane plasmolyze, and use the methane produced to transform the hydrogen out of it. This is a factor of 5 times more efficient than to take this out from electrolysis, for example. So having this in mind, you have a direct link to a storage concept, meaning I do not see the wastewater treatment plant anymore only as producing biogas, burn it in CHPs and try to maximize the self-electricity supply, go away with that. We connect it to, let's say, a future hydrogen net. So both the energy side and the wastewater side, if we now continue with having a full treated wastewater, and often when I discussed with clients and communities, but this is the end of pipe solution. And this is what I want to try to explain. As soon as we go to reuse, it is never an end of pipe solution, because now we have the source and we reuse a water which we require for irrigation, which we require at least into a gray water system if we want. So we replace directly drinking water. And this is, and in this context, the wastewater treatment plant having state-of-the-art technology, full elimination, optimizing the energy part of the one side, and approaching the reuse side with technologies like ozonation or activated carbon. Whereas what I see in Europe is that the ozonation, so you produce ozone and you distribute it in the wastewater, making you add some filtration, so you really eliminate any kinds of difficult and dangerous substances. Also, all what is related to the pharmaceutical part can be safely eliminated. So we have the technologies. This is nothing new. They have just to be combined in the correct way, and the combination in the correct way means that if you do not have a full biological treatment, for example, the efficiency of a disinfection stage, the efficiency of an ozonation stage or whatever is not good, and it's not economic, because you have still carbon inside. If the BOD is not reduced to, let's say, 5 to 10 milligrams, so full carbon removal, it will consume much more energy, will consume much more, whatever chemicals to reduce this and that if you have a treatment process. So all this can be done, and then you can have a safe and clear reuse concept where if you also have economics in your mind. This was discussed previously. I mean, especially in cities or in dense areas, everywhere we have wastewater treatment plants, and they have to retrofit in a really high volume. And now this is the biggest chance which we ever have. The thing is, what is expensive infrastructure? I mean, I've designed hundreds of wastewater treatment plants, so I'm not afraid of this pipes and pumps and whatever is required. Okay, this has to be designed and the engineers can do it. The thing is, if you do it step by step, if you rebuild new districts, if you have to open streets, if you have to make a new district outside, if you install your gray, let's say, call it your gray water pipe now step by step, and it is in the ground, you just have connected, and then it is very cheap to add tertiary treatment processes connected to the gray water. And now you must see, you can reuse up to 100% of your wastewater. Now thinking about the capacity of a big city, what is reduction of drinking water capacity will occur if you do that. So the potential which I see from this part is enormous. But to make it most economic, it has to be determined where can we start effectively. I mean, I do not say that we everywhere we start now open streets and installing pipes. I mean, this would be, of course, crazy. This is not what I'm trying to explain. But we need the strategy, and as soon as we go to rebuild or retrofit areas, this has to be done, and we have to of course make a design for that. Which capacities, which flow rates, which pressure do we need, so that we can install everything which is required, so that it can be connected and used. So in this sense, I think, in addition with nature-based solution, which has to be also done, no doubt about that, with the possibilities to reduce the specific drinking water consumption. What David explained, this must be done. The point is, if at the end of the day, our important water source is decreasing and we come into a real water stress situation where, of course, not everywhere, but you know California very well, you do this reuse concept since long years. It's a different situation there. You have developed reuse concepts in this thinking. So I think such concepts need to be studied. The capacities required must be determined so that we can do it really effectively and step by step, and having another part where we can control the capacity and the volume, the quantity of water which we can reuse, and where we can save directly one by one drinking water. So this is maybe a little bit to summarize this complex issue. So we have both energy and we have this water reuse, where I want to point it out once more, I don't see then wastewater treatment and a pipe solution. It is the beginning of the pipe, because we are going back and will save drinking water.
Thank you so much, Alfred. I think, first of all, I would like to give a chance to our community to ask questions. So if you have any questions, please be prepared. I'm going to go to you next. One quick comment I want to make is I hope everybody kind of sees the connection between these three pieces. I think to Alfred's point, we can do a lot more re-engineering our cities and communities to be more efficient and using our water better, and actually generating energy when we can, and sort of reducing waste, which I think it's very key. And just to give you a sense, according to United Nations, by 2050, 70% of the population is going to live in urban areas, and 60% of those communities has not yet been built. And often when I say this, people say, oh, are you talking about Africa? No, I'm not talking about Africa. I'm talking about everywhere. Think about California. Think about Europe, think about anywhere in the world that you're looking, we are building new subdivisions, new communities, just constantly we are growing as a society. So we have to rethink how we engineer our cities. And I think the next piece of that is what Chingwen was saying with a nature-based solution. Again, like these new communities give us a new opportunity to rethink how we want to build our infrastructure while we are retrofitting the old ones. And I think ties back again to what Alfred said with wastewater treatment plants. If we are reducing our water use, if we are capturing a lot of our storm, does that mean that we need to build different kind of wastewater treatment plants? We consider the size, the type, the style that we do it. And I think going back to David's point, scale very much matters. You have to look at this in various scale and being able to connect all these pieces together. And also you have to sort of start from the bottom, understanding demand, how it changes, where everything fits together, and then going up and trying to bring along everybody to change their mindset and changing their behavior at different scales. And unless we have very good understanding of how these things function at various scales, we really cannot do this systematically. So if I want to give anybody, if you have any questions, please raise your hand. If not, I have a bunch of other questions that I'm excited to ask, but I want to make sure everybody has a chance to ask questions. Any questions? I don't see hands. Nuri, are you, okay.
Yes, I was checking, but I also don't see any. I don't know if Michael would like to make a comment, or Jeffrey, Cecilia.
Okay.
I will start. I don't know if you can.
Yes.
Great talk. I think so. We have seen all these different challenges, and to David's point is people will be able to do it. And what do we see as a gap of like whether we're not successful of communicating this information to people, or what are the challenges that you see the buy-ins from the general public in conservation or in any of these? David, like, I'm surprised you just say if we just all conserve the way that we do, then we don't have this problem anymore.
Well, so I want to impress upon you. I've done tens of thousands of simulations, tens of thousands, hundreds of thousands. And it all comes down to really basic things. And conserving, everyone using just a little bit less water, reducing, here in the West, reducing outdoor water demand. That's the big water user. I think I said this in my talk, but up to 75% of water use in some communities here is outdoor water use. So reducing outdoor water use, conserving water, those really are effective measures. And educating people, I know it's a constant struggle to educate people about where their water comes from and how to conserve, but it's just something that we have to do, I think.
So I guess I have a question.
Oh, go ahead, Michael.
Which is, and Alfred, thank you for laying out the three segments we've heard, and there are three very clearly different approaches here. And maybe that's just the way it has to be, but I'm wondering, is there any, research gap to be filled here that would integrate these silos in thinking about water? Or do we just proceed in our silos?
May I say something? So I had a paper that came out in Sustainability Science not too long ago where I looked at gray water use, but decentralized gray water use and rainwater harvesting, and how we can use those sources to meet outdoor water demands here in the Phoenix metropolitan area. So I'm not sure we're completely siloed, but
Fair enough.
And also the modeling I do does look at reclaimed water and direct injection of reclaimed water into the aquifer. So we're definitely looking at those types of solutions.
That's an interesting thought. I guess that might be an alternative to what Alfred is saying about laying pipes back to all the neighborhoods is regenerating the aquifer. In some cases, that might be more feasible.
Right, and also I would argue decentralized gray water
Yeah.
systems. They don't have to. Now I understand why centralized is a good pipe. I mean, you reduce flows in the pipes, you have problems with solids making it to the treatment plant. I mean, there's some real issues about that. But in some cases, I think decentralized systems work fine in capturing rainwater as well.
Absolutely. Yes, I mean, I do not say that, or also here the other way around. Everywhere outside where you can apply decentralized systems to reduce the water consumption, having a separate system for gray water treatment and so on, has to be done. But always keep in mind that in total, the volume which you treat there is not the volume which we have to achieve to reduce the total drinking water consumption to a level which we should achieve in total. This will be, for sure, a solution in these areas, but it will not be a solution, of course, in the dense cities where it is not possible to apply these decentralized systems. And I discussed this within our research project very intensively, but in general, it's always discussion that people like to have this idea about decentralized systems. And I have also an idea about decentralized, but decentralized in terms of when you go to water reuse and when you go to have a really full efficient treatment, you need a certain size. You cannot break down decentralized system to like 50 people or 100 people systems and treat this and have a gray water system. This, you have to do it outside. You have no other chance. And this is it must be done. So I don't say this makes very much sense. So decentralized, and what Michael mentioned, recharge. Recharge is a very important thing, but you need to have a water to recharge and to refill the groundwater. Mm-hmm. What I'm saying, if I save the drinking water capacity from the beginning, I recharge in this sense that I take less of my reservoirs out, and I protect also this. This is a socio-economic thing, which I don't know if we have time to discuss it, but now we are drinking the really old and good groundwater, which was, if you look in detail, hundreds of years in the ground. It's an extreme good quality. But if it happens that the groundwater level reduces, our children, they will have a better quality. We will take this good water out, add pollution, and if you don't work against that, it's a real problem. From my perspective, also a socio-economic problem. So either recharge if you have a possibility, but this is also done in big cities. It's often done, but you use at the end of the day also wastewater, which is advanced treated, and where you go to areas and recharge it so that you have an effect on your groundwater systems.
Okay, I know Chingwen want to answer, but I also want to make sure our students have a chance to ask questions. And I know Shreya has raised her hand and want to ask a question. And then hopefully we can stay on a little bit, maybe longer, and have a broader discussion. Shreya, do you want to ask your question?
Thank you so much. First of all, thank you to all the panelists and professors for arranging this. This has been a really great session, understanding water, urbanism, and all the aspects that we've been talking about. I have a question, not to any specific panelist, but to everyone in general. As in the beginning of the session, Professor Chingwen mentioned about how nature-based solutions are important, and also Professor Alfred mentioned that it's important to protect groundwater and advanced wastewater treatments. As much as these are really great ideas and they are to be implemented, I also feel like at the alarming rate at which the climate change is taking place in all over the world, we are at a time constraint. So as a graduate student, as someone who is going to be graduating soon and going to be in the industry to work and execute these solutions, where should be a starting point? So all of these ideas are really great, like we can see them being implemented, but how do we start and where do we start from? Because we need to make the change. So I just had this question.
Oh, good question. I think that I can also kind of respond to the decentralized design issue too. So the many even whether public or private sectors have started to think about how they can be more responsible on their own sites, right? So for example, city of San Francisco, the water department, they have, it's in the building, it's in the downtown, and they have a decentralized wastewater treatment on site. And I have seen that other cases in Portland as well. So that actually gives us maybe a new perspective of what we can do with more decentralized solutions, which I think eventually, I think it's more economically effective, right? And alongside with that, I will actually encourage also thinking about technology innovation. So the way we are dealing with like toilets, right? We use a lot of fresh water to flush a little bit urine and stool, right? And actually there are some technology already try to separate the urine and the stool. So you can have separate treatment because one is liquid, one is more of a solid. So again, it seems minor thing, but if I think even from the really small scale thinking how we design those systems, right, the wastewater treatment systems, and then to think about what could be a more beneficial. I mean, for the community scale, I've also seen, right, in the subdivision that you can have your on-site treatment as well. So it is possible if every community, do their own diligence and solutions, it's possible to do. And of course, if there's exceeding that capacity, we can think about, the supplement. So there's resilient designs and you have different modules and work together. Right? So that would be one of my insights to this.
Thank you, Chingwen. I think that's it. I wanted to mention San Francisco too. I think there's a lot of opportunity to do distributed in the existing systems that we have, and definitely San Francisco is a great example of that. I have Lohita who has a question, and I would like to have her ask her question herself rather than, I know she put it in the chat. Lohita, do you want to ask your question?
Yeah, sure. Am I audible?
You are audible.
Yeah, so I had a quick question about rainwater harvesting, because I know I'm from India and it's like a big thing over there, like most of the houses have it there. Like since we're talking about water reuse, and would that be a good solution at least for non-potable purposes? Because in some cities, I feel like you're going to definitely have abundance of rainfall, because I was in Pittsburgh for 2 years, and there was a lot of water just going into surface runoff and just entering the gray water directly. So instead, if we had to collect it and at least reuse it for the other purposes, I would like to hear your thoughts on that.
Yeah, so definitely this technique has been used for decades in the US as well. So people use, you can use smaller scale rain barrels. Each residential, you can do it. A bigger scale can be a cistern. It can be above ground or on the ground, and people do use that. In Arizona, Tucson is a good example. They've been really promoting that for years, and it's been very effective. So every city, everywhere can apply, but that's of course is voluntary, right? There's no regulation say you need to do this. So, but there are some incentives in policies, for example, to if we think about water use, the fees adjust that, and there are some stormwater runoff discharge fees from your lot, this can provide some incentives, although I have not seen that very effective. Sometimes it's too small to be effective, the fees. So it's a lot of things how we can think about multiple solutions together.
Yeah, it might be a good idea. So at present in Arizona anyways, there's no laws on whether you can capture rainwater or not. I can foresee a time, I don't know how far down the road, where that actually might happen. Maybe you could get grandfathered in if you start collecting your rainwater now before those laws go into effect. I don't know.
Mm-hmm.
I think along the same line, I have David who asked the question on chat. I want to see if David want to ask his question.
Yeah, I was just curious, like, how do you feel about the quantity of like wastewater treatment plants, considering like there's a large, population growth in California and, those states? How do, is that a factor like for conservation?
The wastewater treatment plant, they have different stages, right, to treat water. And so most of, so when we hear about some kind of nature-based solution to be in company with wastewater treatment, usually it's alongside with gray infrastructure and green infrastructure. So usually the constructed wetland, they are most effective, probably on the last stage of the treatment. That's how it has done in Phoenix, for example, here. They build a huge kind of, constructed wetlands to treat the last stage of wastewater treatment. And then they counted it's more effective, money-wise, and then you provide other benefits for the ecosystem. So, so it's a combination. Think about the technology and the amount of and type of wastewater we are treating.
Yeah, I think one comment quickly I make here, David, is also you brought up a very important point, which is sort of how do you sort of create a balance between demand change and future infrastructure. And what we see right now at the utility business, often the projections have been and still continuing to be that population growth is directly related to demand growth. And what we have actually seen in the past 40, 50 years is these two has decoupled. So the population growth doesn't necessarily lead to demand growth because there's so much inefficiencies in the existing system. So actually there's a lot of discussion around, are we really building infrastructure to the right demand, or are we just projecting, are we having this old school approach to demand and trying to continue on the path of increasing supplies because there will be a demand for it at some point somewhere?
Yeah.
Go ahead, David.
Sorry to interrupt you. Yeah, and it can be a complex issue because everyone seems to think that by increasing residential housing density, you're automatically going to decrease water use. And I have a paper out right now in review that says that that's not necessarily the case either. So it's built upon also how efficient we're irrigating the green systems that we have. So it has to do with, it is decoupled, and I don't know how we would ever, I don't know a better approach yet other than trying to still use population and per capita water use yet. It'd be a nice, interesting challenge to try to figure out a finer tuned way of looking at actual water use. Sure.
And I think we have two more, sorry, we have two more people waiting to ask for the chance. We have Manpreet and we have Michael's phone. I don't see the last name, sorry. So maybe we can do this too quickly, and I think we pass the time, but if everyone is okay, I think we are okay too.
Manpreet, go ahead.
Good afternoon, everyone. Thank you so much for this session. I think it was really informative. Got to learn so much about the research going on. My question, actually I have two questions. The first one is when we think about retrofitting, Professor Chingwen suggested that we should design the city in a way where we allow the stormwater to navigate through the city without demolishing the existing infrastructure. But at the same time, I have a doubt, and it has always been a concern for me as an architect and as a designer also. So how should we consider that designing part now that we have an existing infrastructure already? We cannot afford to demolish any infrastructure based on financial limitations also, and also their communities already built. How do we see an approach towards that issue where we allow the stormwater to navigate through the existing infrastructure in a way that it does not disturb the grid, the pattern which is already there? And the second question is, when we talk about wastewater treatment plants and many more strategies and so many research work done, I think we should also consider one point, that there are so many parts in the world, like so many communities, where still people or cities do not have exposure to wastewater treatment strategies and plans. There are so many parts of the world where we do not see conservation techniques taking place. People are not getting educated. There's so much information floating around in the air, but still there are so many areas and cities which are lacking in terms of those facilities where we do not have wastewater treatment plants in those areas. So, I mean, I think those people and those cities, or you may say those communities, are lagging behind because there is a lack of availability of even fresh water. Forget about wastewater treatment plants. So how do we consider that, and how can we contribute at this as urban designers when we design, so that we make them at least available, like at least be approachable to not even max, but little bit of those facilities and those information?
Well, thank you very much for your questions. And it's really good and tough questions too. It's not easy to, it's true, it's not easy to retrofit to existing cities fabric, especially if there's no investment going on. I can see, well, it really has to, well, it depends on the scale, right? So if the city can identify, at least even if the neighborhood we can touch and or they don't have money to renovate, but can there be some upstream, downstream solutions to mitigate, right? So can we hold water upstream, downstream? If they have to be a little more holistic looking, the solutions, not just looking at the neighborhood itself. So there has to be collaborative effort beyond that boundary to think about the watershed scale, how we manage. So the multiple other solutions could be applied, to in combination. So that's probably one one way I can think about how we may address those issues. The education and how we provide solutions to let people to have access to those infrastructure and facilities. Well, definitely it needs education. That's first thing we can help, right? To communicate with community. The technology also, I have seen scientists trying to develop, some, I've seen a toilet that can actually kind of separate and clean or something, like they can install in a side without connecting to sewer system. So things that kind of, innovations, I mean, for all the fields, it is no one solutions in one field. So I have to work together to think about innovations to help to address those issues.
Thank you, Professor Chingwen.
Perfect. So I think we have one, Michael, who's calling from his iPhone, has a few questions about bottling, water bottles, and the issue with access. So I'm wondering if he wants to ask his own question, and then we have our panelists answer those. Okay, Michael. Okay.
Yeah, sorry about that. Can you hear me?
Yeah.
We can hear you.
Yeah, this is just a curiosity more than anything else. David Sampson had said that the amount of water consumption in Arizona more or less stayed steady, even with population growth, and maybe that was due more towards the less agriculture in the area. But I wonder globally, like how much water is produced and bottled and shipped around the globe. That is anybody capturing that data as supplanting, water that's consumed in the home?
So I would like to comment on that. So reduced ag in Maricopa County is only part of the reduction. It's really more about efficiency in appliances and fixtures going into the new homes, as well as reduced lot sizes and changes in outdoor landscaping. They're having greater effects on total overall reductions in water demand in Phoenix metro area. I haven't looked into the water bottling challenges at all myself.
Okay, thanks.
Okay, great. So we're about 15 minutes over time, but this was such a fun conversation, and I appreciate the panelists staying on and for sharing their insights and time with us, and for all the audience who stayed on and asked all these great questions. With this, if there's no other comment, I'm going to pass it on to Cecilia to close this engaging series and use the close.
Yeah.
Gavel.
For the RCN leadership, I just want to say, Newsha, thank you for moderating.
Of course, that was my pleasure. Thank you for the opportunity.
Yes, thank you.
And thank you to all panelists.
Yeah, thank you everybody for contributing to this great discussion. And I think the students have benefited a lot also learning from different perspectives. So I would like to close the session, and if you're interested, I think David has a few publications. If you would like to share, feel free to send it to Nuri. Nuri can post it on our website, and so we have our LinkedIn page and YouTube channels. Feel free to reach out if you have any further questions regarding modeling, regarding a technology in wastewater treatment plant, of course, policies. Newsha has a lot of experience in policy making. Of course, nature-based solutions from Chingwen. So feel free to reach out to our members, and we will make whatever is available to everybody, so you can use it for either learning purposes or reach out to your own stakeholders. I would like to close out the session. Thank you, Newsha, for hosting this and giving the insights on all these nice questions. We'd like also Michael, Jeffrey, and Nuri, the organizing committee. We have a wonderful run for a couple of these sessions. We are going to take a little break next month since we are starting our semester, and in October we are resuming our webinar series. We are going to focus on community engagement. So we look forward to having everybody back, and please stay tuned. Wish everybody a happy end of the summer. Wish it doesn't end, and a wonderful beginning of the semester. Thank you, everybody, and have a wonderful Friday.
Thank you.
Thank you.
Thank you. Thank you.
Thank you. Thank you all. Bye. Bye-bye.